Good evening, everyone, and I welcome you all to this fourth lecture series that we are having on data and data professionals and explaining the basic concepts of data. So, in the last three sessions, we focused on the past and the present, what different data professionals are, what different kinds of what a system looks like, what different roles are, and what are some of the tasks that a data professional performs. Now we are going to moving in the from the rear view mirror. We are going to move to the crystal ball. Now we, as you can see on my screen, it's a crystal ball, and we have already all seen that cartoon or that movie where witch or person tries to fortune teller tries to predict the future looking at the crystal ball. Data scientists are a little bit like that. Well, they don't have witch like dresses and they don't have a crystal ball to predict the future, but they do have other tools to predict the future, and that's what we are going to talk about, predicting the future. And it might seem a little bit fuzzy because well, how can someone predict the future, right? Well, people can predict the future with certain level of accuracy, with certain level of confidence. So that's what we are going to talk in details in our lecture today. Now these predicting models. So in machine learning, we have models instead of crystal balls that uses data to predict what's going to happen in the future. So that uses previous information and finds hidden patterns to show what might happen in the future. Now, this is the central function of a data scientist, and that's what gives the entire field its power and futuristic edge, being able to predict. Okay, so predictive models is basically, if we want to look at the formal definitions, predictive modeling is the process of using historical data to build a set of rules or an algorithm that forecasts future events. That's the official definition, and the easy definition is looking at the previous pattern, you recognize and you predict the future. For example, when we were growing up, we saw a lot of, in summer you used to see you used to hear the ice cream trucks on the road and hear that music, that familiar music that we hear when there are ice cream trucks around, right? Now, if it's the month of December and someone comes and asks you, hey, how many ice cream trucks do you expect to see in this month? Do you think you will be able to predict this? You definitely will be, because it's the month of December and it's probably winter, right? So you don't see ice cream trucks driving on the roads when it's snowing outside, right? So it's very easy to predict. Now, why was it easy for us? Because we had a lot of previous historical information and our brain processed it to say that, hey, in December, you don't expect any ice cream trucks moving on the road. So that's one example of looking at the predictive power. Now, let's start by looking at the real life models, talking about the real life ways that machines or a data professional or a data scientist makes a machine predict the future. Now, there are two ways of learning. Machine learns in two ways. First is supervised, the other one is unsupervised. Now, all sorts of prediction work. So if you see any kind of prediction work, you could classify them into either supervised or unsupervised. Now, what is supervised learning? Supervised learning involves teaching algorithms with labeled data. Now, what do I mean by labeled data and what is supervised learning? Let's take a very simple example. Teaching a toddler. You have a kid, or you have a friend, or you have a cousin who has a kid and who is learning to talk, recognizing objects. Hey, when he or she sees a car, he said, there's a car, there's a air conditioner, there's a ball, things like that, right? How do you think the toddler does that? So he sees something, tries to recognize a pattern, and whenever he sees something new, he tries to fit his pattern image, the pattern mapping, with the new object and figure out what it really is. Just to give you an example, think you are showing a toddler a red, round, plump apple. just like the one in the picture. You are showing this apple to the toddler and telling him, hey, this is an apple. Then you come and you show a green apple, or not green, entirely green, maybe mixture of red and green. Okay, and so this is also an apple. Then you come with a banana, a yellow ripe banana that has a lot of those dark spots in it, and you say, hey, this is a banana. You show another banana that has a greenish texture, not very ripe one, and you tell the toddler, this is also a banana. Now, the next time when the toddler encounters an apple or a banana, so this is how he's going to think. Apples are red or greenish in color. They are small, round. Bananas are yellowish in color. They're long and they're a bit larger in size in terms of length compared to apple. Now, when you show the toddler that an apple, a green apple, what happens? That toddler mixes, okay, the shape round matches with an apple. It's small, matches with an apple. The color, well, I know apples can be red and apples can also be a little bit green, but my object in the that's being displayed is green, so maybe it is an apple, and there you go. Now he has registered that, okay, this is an apple. Now, why have I been talking so much about apples? Because I can understand that this is a very simple process that we go through every day, and you would be like, hey, why are you even talking about all these things, right? So because this is the exact model that machine follows to learn. So whenever we give machine a data, it simply processes the data in a way that it is able to predict things ahead of time. For example, in Netflix, you have watched 50 movies. And after you watch a movie, you have that option, right? Like and dislike, right? So if you watched 50 movie, you either liked the movie, you gave a like, or you gave a dislike. And all these 50 movies now are labeled. Person of Superman, the new Superman, like. The new Batman movie, like. The new XYZ movie, dislike. So Netflix figures out, okay, out of the 50 movies he watched, he liked 30, and amongst the 30 movies, 20 of them are labeled action movies. So Netflix can easily predict that you are a person who likes action movies. So now imagine you are confused about, should I watch movie A, movie B, movie C? Maybe watch that new Mission Impossible movie. I have the option to watch a new romantic movie and a horror movie. So action, romantic, horror. And if Netflix sees your previous history, he is definitely going to recommend the new Tom Cruise movie, the action movie, because he knows you like action movies better. And highly likely you will also like the new Mission Impossible movie because you are a fan of action movies. And that is how Netflix is able to predict what user will like. So looking at the type of content that existing users watch, Netflix creates new content that is sure to be successful. So if he sees that a lot of his customers, Netflix's customers, watch horror movies and they really like the kind of horror movies the makers at Netflix makes, so Netflix will ask its directors and its producers to produce more and more horror movies because my customer base likes horror movie, and it's likely that if I make a horror movie, it's gonna sell in the market. Now, the second example of machine, so we talked about the first kind of learning that machine does, that is supervised. When we give them a data, we give them a label data. Now, in a production world, imagine the exact same thing, but in a different way. For example, instead of 50 Netflix movies, you have data about 50 million people. So that's what a data scientist does. So if I had 50 movies, I could manually label them and check them. But now that I have 5 million or 50 million data sets, I cannot manually do that. I need a person who knows how to work with large data sets. And that's where a data scientist or a data professional comes in, or a data analyst comes in. Now, the second topic is learning without answers. Unsupervised learning reveals the hidden pattern in data sets. So when you have a data set and it tries to reveal a hidden pattern, let's say you're hosting a party and you ask your friend, hey, can you go and check how many people wants soda, how many people wants apple juice, how many people wants orange juice, or people prefer Fanta. So you have two options: Coke, Fanta, apple juice, orange juice, right? These are the four kinds of drinks that people are having. But what he does is, when he collects the list of drinks, he doesn't specify, hey, Mr. X wants apple juice, Mr. Y wants orange juice, right? Because that's probably not a realistic thing to do. He just counts that, okay, I need 50 orange juice, 50 mango juices, 50 sodas, and 30 Fantas. He comes with a total grouping breakdown, and the person who is making the drinks, he makes all the drinks together and he sees a pattern in the mixed up data. He sees that, okay, I have fruit juice, either apple or orange, that's one type of juice or drink, and I have cola, that is either Fanta or Coca-Cola or Pepsi, whatever it is. I can separate them. I don't need to know who drinks what. So, or instead of all the people coming to one place, I could simply separate them in groups, right? So I place the juices in one side and I place the colas in one side. So I have grouped them. Although I don't know who is going to get what drink, but I have made it easy for the person to find his drink. If he wants a cola, he should go to the right table. If he wants a juice, he should go to the left table. Now, I can also do further clustering, further grouping. That is, in the juice section, I could do orange juice and apple juice, right? So I could keep all the orange juice people together, all the apple juice people together, and I could simply tell people who want orange juice, go to the tables on the left, people who go to orange juice, go to the tables on the right. So that makes the job very simple and easy. And not just simple and easy, it helps me recognize a pattern. So this process that I did, that getting separating drinks into two groups, juice and cola, this is called clustering, okay, or unsupervised learning. I don't know who wants what kind of juice. I just know what the products that I have. That is, in this case, all the drinks is like my raw data. I don't know what to do with this data. I don't know who to serve. I don't know who to give this data to. So instead of trying to figure out who wants what drink, I start separating the drinks so that people who needs the drink can themselves come and get the job done. Now, in an unsupervised learning model, we do something very similar. We give the machine the entire data set and the machine tries to predict its data or cluster the data. And based on those clustering, it finds relationships, it finds hidden patterns, it finds some kind of characteristics. For example, let's talk about Spotify clustering. When Spotify uses its listening data, just like the Apple, unlike the Apple example, it doesn't tell Fuad bin Saif listened to this song, this person listened to that song. No, they don't do that. What it rather does is, it simply dumps all the data into its machine learning models, into the machine, the model that it has created. And this model starts clustering. Okay, this group of people listens to this kind of music on a evening. This group of people listens to this kind of music on a stormy night. Now, then Spotify analyzes the kind of group of people who listens to this music on a stormy night. Let's say, who is listening to rock music on a stormy night, right? And he analyzes the characteristics of those people. And now when I join Spotify, Spotify sees that the characteristics of those group of people who were listening to rock music on a stormy night meets the characteristics of me as a person. So it figures out, okay, so I can be clustered into that group of people who is listening to rock music. So it will start and if suggesting me more and more rock music, because my characteristics, my personality, my behavior matches the behavior of those people who listens to a lot of rock music. So just by giving raw data, machine can still find out patterns, recognize patterns, and make informed business decisions out of it. Now, we were talking about two basic kinds of clustering, or two ways that machines are able to predict data. Now, I don't want to get too technical, or too much details, too much mathematics into the concept. So I am touching more of a foundational idea of data, right? And so another core foundational idea of data is the neural networks, or deep learning. So deep learning is basically, so just to be clear, deep learning is one kind of neural network. Okay, now what are neural networks? So again, the thing of super brain. Neural network is basically a system that our brains use. By the way, you are holding the most powerful and the most efficient machine learning model that was ever created. It's over here. Our brain is able to process huge amount of information in such record amount of time that no machine, no nothing can replicate that. So it's really fascinating how our brain is able to process such huge information and at the same time not remember to purchase that grocery item that we ran out of last week, right? So that's the thing. How do we do that? Our brain works in a form of networks we call neural networks, and when technicians or computer scientists, when they were developing these models, they saw that, well, this is since our brain can process information like this, let's replicate that in machines and see how does that work. And they found tremendous success replicating the model, the learning model that's inside our brain, and it is called neural network. Now, what neural network is basically, it looks at an information input, it has a hidden layer, and it has an output layer. So it has three layers. I use my eyes to get the information, I'm using my brain to process the information, I am using my mouth to give out the output. So this eyes, brain, mouth thing happens on inside our brain as well. We have receptors, right? So just like that, in a machine learning model, it has receptors and several layers. So it has the receiving layer, and it has a different layers, right? It has a receiving layer, it has a hidden layer, and it has an output layer. Now, what deep learning is basically when there are several layers. So in neural network, as long as there are neurons, like input, process, output, we can call them a neural network. But deep learning must have several input layers. Now, important question, why am I talking about neural networks and deep learning? Because it's the foundation for AI and all the things that you see. Okay, now imagine Mona Lisa art inspector team, right? You're expecting the inspecting the photo of Mona Lisa. I'll be honest with you, I am not very good at deciphering the art, and probably call me uncultured, or in that term, that I am not the best when it comes to understanding art. But for me, it's just, hey, it's a painting of a girl. But the person who understands art, who understands this drawing, he will observe the picture, he will try to understand things, which I will never understand, of course, and I don't want to understand either. But computer does the same thing. It has several layers. So when I have given it an image, the first layer will only look at the raw edges and colors. Okay, so for example, it will look, okay, it's a picture, it has sides, it has four sides, there are different colors in the picture, so we can say this is a picture. Now the second layer will probably look at Okay, now that we have established it's a picture, let's see what happens inside a picture. Okay, by looking at the shape, by looking at everything, the way colors are distributed, we can say there is a human being sitting in the picture. So that's what the second layer does. So you see, each layer is specialized to process one specific kind of information. And once it processes that information, it passes the information to the next layer, and next layer does the next processing. So just like that, layer 1, 2, 3, 4, 5, 6, let's say layer 5 is the specialist. He combines the edges into complex shape, an eye and a nose. So it's now that it figures it out that it's a human, right, in a Mona Lisa image, it's trying to figure out where the eyes are, where the nose are. Like when you draw a picture, it's very hard to sometimes figure out where the nose and the eyebrows are, right? So the specialist figures that out. And if we go down more layers, for example, layer number 10 is the expert layer. So that layer does not already knows it's an image of a lady. It has eyes, two eyes, one nose, one whatever it is. It's the picture of Mona Lisa. So it has all the information already. The expert layer now focuses on the subtle relationship between all components and understand the final expression and style. Is Mona Lisa really laughing, or is Mona Lisa really just looking at the picture? So what's going on? So it analyzes the image, the subtle relationships, because now it's easier to analyze in the expert layer because it knows it's an image and it's the image of a lady. So it can bring in the expert layer in order to analyze a picture. So that is how neural network and deep network works. Now I can understand this lecture might get a little bit complicated for you guys, so I'm not going to extend it too long. I'm just going to end it with a summary of what I have talked about. Just a second. So we started with predictions, right? We knew that data science, one important job of our data professional is data scientist, and data scientist does a lot of predicting. And then we tried to figure out that how we do this predicting. In order to, just like a toddler learns from an apple, seeing in the picture of an apple, we are able to predict the, we are able to predict the, we are able to teach the machine what an object, what an image is, and once the machine learns from it, learns to compare it, it's able to predict some simple things if it's labeled. Now, in the real world, all the time we do not get labeled data, right? So sometimes we, for example, someone listening to music, or someone liking a post, or a lot of things, right? Whenever you are trying to measure public opinion, or whenever you are trying to analyze human language, textual languages, so it's not always possible to label data. So there is another way using which machines can learn about data, that's called unsupervised learning, where we don't label the data, we just give them the raw data and hope that it can cluster the data nicely. An example of unsupervised learning is Spotify. Then we talked about neural networks. We said what neural network is, and we also explained that deep learning is nothing but several neural networks. By the way, these all artificial intelligence thing, AI, ChatGPT, Gemini, all those things that you see, they use deep learning to train their models. And finally, once we have all those things, we have trained the model, we are able to predict. A data scientist finally creates a model where it knows if I give this amount of data, my model can predict data, can learn from this data and predict results with a 98% accuracy. So that's the job of a data scientist. So that's it for today's session. We talked, so we tried to learn the work and life job of a data scientist, particularly today. And we talked about future predicting models. So that's it for today's class. I hope you guys, if you have any questions, I have my email address over here. Feel free to email. I have my LinkedIn ID in the screen as well, so you can add me up on LinkedIn. And if you have any questions, you have my email address. Feel free to ask all the questions that you want. Thank you so much for today's class.